Good morning, class. Today we will discuss the topic addressing modes of 8051 microcontroller. Okay, so have ক্লাসটা স্টার্ট হতে দাও, আমি ঠিক অ্যাটেন্ডেন্স নিয়ে নেবো। রাহুল সিং প্রতিদিনই হওয়ার আগে একটা কোশ্চেন, স্যার অ্যাটেন্ডেন্স নিয়ে নিই। অ্যাটেন্ডেন্স নেবো, দাঁড়াও, ক্লাসটা আধ ঘন্টা ক্লাসটা হতে দাও, তারপর অ্যাটেন্ডেন্স। ঠিক আছে, ক্লাসটা তোমাদের 50 মিনিটের, তো আধ ঘন্টা পরে আমি অ্যাটেন্ডেন্স ঠিক নেবো। ওকে, সো অ্যান্ড এরপরে আমি আর একটা কি দুটো, বেশি নয়, আর দুটো হয়তো পিডিএফ শেয়ার করব। 8051 কমপ্লিটই হয়ে যাচ্ছে আমাদের। তো এরপরে আমরা জাস্ট একটা ইন্ট্রোডাক্টরি পার্ট অফ 8086 স্টার্ট করব। সেটার একটা, হার্ডলি একটা বা একটা পিডিএফ তোমাদের হয়তো শেয়ার করব। আর আর একটা পিডিএফ আমি এটা শেয়ার করব, সেটা তোমাদের মানে সাজেস্টিভ কোশ্চেন। ঠিক আছে, তো সেটাকে নিয়ে দুটো দুটো পিডিএফ আমি এরপরে শেয়ার করবো, then it will be over. Okay, so after this 8051 we will have our next topic, that is 8086. Yes, MCQ type. In ESA you have to answer MCQ type questions. Okay, but that MCQ will be little differ from your MTA MCQ, because MTA is MTA and ESA is something bigger than MTA, right? So 60 marks. Yes. ইয়া, ওটাই তো আমি তোমাদের একটা পিডিএফ শেয়ার করবো, যেখানে সাজেস্টিভ কোশ্চেন, স্যাম্পল কোশ্চেন কিছু থাকবে, তোমাদের তোমরা সেভাবে প্রিপারেশন নিতে পারবে। Okay, so let's start today's topic. Okay, so it is already 11:30. So addressing mode is, we have already covered this topic in 8085, right? So in the 8085 we have 5 addressing modes. Similar to that, 8051 also has 5 addressing modes. Okay, and you see, uh, among those 5 addressing modes, first four are similar, same, right? Because like register addressing modes, it is also present in 8085. Direct addressing modes, it is also present in 8085. So am I audible, everyone? Am I audible to everyone? Okay, so register addressing mode, it is also present in 8085. Direct addressing mode is also present in 8085. Register indirect, it is also there. Immediate also there, but only one is different here. You see, this is base register plus index register indirect addressing mode. Okay, so this is this addressing mode is not in present in 8085. So so what is the fifth addressing modes of 8085? Means there is register direct, register indirect, immediate, then there is another one, as there is no base, implicit. Yes, implicit addressing modes, right? So here in that implicit addressing mode is not present here. In here the addressing mode is base register plus index register indirect addressing mode. Okay, and the architecture of 8051 is different from 8085. So for that reason you have this table. Okay, so So you see the table one actually it is showing you the addressing mode and the associate memory space. So why this table? Because in 8085 we have only one memory space for storing your data and program everything. But in 8051 we have two different memory space, right? For storing your program and another one is storing your data. Okay, so for this two different memory space we have five different addressing mode, and five different addressing mode will affect different memory space at different in different way actually. Okay, so you see, suppose for the first one, register addressing mode, when I'm taking this as example, register addressing mode, that means I'm interested only in the register. Okay, so how many registers are there in 8051? The answer is R0 to R7. That means 8 registers. So how many register bank presents in 8051? 4 register bank. So in that 4 register bank, in each bank there are 8 registers. So 4 register bank, in each bank 8 register, that means 4 into 8, 32 total registers. So basically this register addressing mode will take the memory space where these registers are exist. Okay, so it will hit at that memory locations. Apart from that register bank, it will also hit or associated with the accumulator, because the accumulator is also a kind of register. Okay, okay, so and register B, so register B is there. Okay, so it will also coming under this category. Okay, then your DPTR, data pointer register, so it is also a register, it is also coming in this category. And the carry actually is not registered, but but it is your flag. Okay, so here is little different, this concept is here changing some to some extent, because carry is not part of your register addressing mode. But why it is in this category? Because the answer is written here. The answer is like this: the 8051 is capable of handling bit by bit data, right? Bit by bit data, each bit it can handle. So if I take a single bit data, then how this single bit data behave? It will behave like a binary boolean, right? 0 or 1 binary combination, boolean combination. So 8051, when it is handling a data having only one bit, okay, suppose you are adding two data having only one bit, 1, and another data is 0, so 1 plus 0 1. So that result, it is not possible to store in a accumulator, because accumulator has 8 bit length of 8 bit length. So rather at that time, whatever the operations are performed by the 8051, when it is handling bitwise data, it will take carry flag as a accumulator. So I have written here carry used as accumulator when 8051 working as a boolean processor. So boolean processor means single bit processing, first of all. So when 8051 is handling working as a boolean processor, at that moment your carry flag is acting as a accumulator. So accumulator is nothing but a register. So that's why this carry is coming in this category. So this is the answer. So this is the register addressing mode. So register addressing mode only affect those memory space which are register, accumulator, register B, DPTR, and carry. Okay, it will not affect any other memory locations. Okay, so next is your direct addressing mode. So in the direct addressing mode, what happened? We are providing the address of the memory location. We are providing the address of the data, that is located in some memory location. Okay, so in the direct addressing mode, we are not providing immediate data, we are providing the address of the data Okay, so here also some address locations I have to give, okay, here in direct addressing mode. So that means I have to take the memory space where the memory locations are available. So that means I have to go to RAM or ROM. So ROM actually is your program memory. So what I can where I can go, I can go to data memory, that is RAM. So that's why it is here. For direct addressing mode, it is here written that lower 128 byte of internal RAM. So what is the size of internal RAM? We know that is 128 byte. So that 128 byte of internal RAM is the is used in the direct addressing mode. Okay, and apart from this also SFR registers. So SFR, that is special function register. That registers also used as a location of the data. So in the direct addressing mode, we have to provide the location of the data. So location of the data may be the location of RAM 128 byte or location of SFR. So this is considered as direct addressing mode. Okay. So data can be present in any of these two locations here in the direct addressing mode. Okay. So next is your register indirect addressing mode. So what is register indirect addressing mode? So in 8085, what we have seen? We have seen that in this case, register indirect addressing mode, we are providing the address of the data indirectly through the register pair, right? Using some register pair, we are providing the address of the data indirectly. So that's why it is called or is known as indirect register addressing mode. Okay, so similar to that also here you see that internal RAM is used because it is the data memory. Okay, and internal RAM locations. So whole memory space of the internal RAM is used. And which register we can use in 8085? We have to use, suppose in 8085 what we have used? We have used register pair B C D E H L. Okay, but here we have to use register R1 and register R0. So register R0 and R1, this only these two registers we can use as to for indirect register indirect addressing mode. Okay, and you see at the rate we have to provide this character. Okay, whenever we are using register indirect addressing mode, we have to provide this character at the rate R1 or at the rate R0. So these two register actually register pair is required in 8085 because memory location size is 16 bit. Okay, but here in in 8051, the memory's location size of internal RAM is only 7 bit. So 8-bit combination is enough. So 8-bit combination means one register is enough to locate a memory location of internal RAM. So that's why here only one register we are using, and only R1 and R0 we are using. So we have for each and every bank we have R0 to R7. Among that R0 to R7 we have to use only R0 and R1. Why like this? Because only for these two registers the hex codes, corresponding hex codes are available. For there is no other hex codes available for other registers. So this is how this thing. And next is another part is stack pointer. So similar to that, stack pointer similar to 8085 also. Stack pointer is a in 8085 stack pointer was 16-bit length of register, special register. Okay, here it is 8-bit length of register. So that means stack pointer can be used as the internal RAM location to point any internal RAM location. Okay, so through this stack pointer we can take or give take out some data or put some data into this location. Okay, so stack pointer can be used in this purpose. Okay, so you understand that in the register indirect addressing mode, it will actually it will target the internal RAM where the data can be saved, and from that internal RAM location through register R0 and R1, indirectly we can pull out pull out some data, or we can put some data into it. Okay, so okay, so next is your immediate addressing mode. So in the immediate addressing mode, the data is provided into program memory. So you just try to remember, the program memory not only used to provide the program, it is also used to store some fixed type of data. So immediate addressing mode, in the immediate addressing mode, the fixed type of data are stored in the program memory. Okay. So next is your base register plus index register in direct addressing mode. So this is not present in 8085. So actually it is present in 8051. It is like this. It will target the program memory, and the format is, as you can see here, base register is one part, another is index register. So index register is your accumulator, and base register is your program counter or DPTR. Actually it is quite similar to the jump instruction in 8085. So suppose you are executing some at some memory location, you need to jump to further say further some other memory location. At that point you can use this kind of addressing mode. Okay, so it will actually jump the program sequence from one location to another location. Okay, so this is used for base register plus index register indirect addressing mode. Okay, so basically why we are studying like this addressing mode with memory space, because 8051 has a different architecture with respect to your 8085. So that's why we have to study in this format. We have to study in this format. Okay, so here is a little description of what I have said. In register addressing mode, you see 8 working registers of selected register bank are used. Okay, 8 working register of selected register bank are used. And accumulator register B, DPTR, carry also used here. Okay, so it is I have note is given. Boolean processor is as 8051, so carry is used as your accumulator. Then next is your direct addressing mode. So in the direct addressing mode, this is the only method to use or to access the SFR. Okay, so this is very important. The SFR means special function register. So special function register, we have some instruction to access this or special function registers. Okay, so those instruction coming in the group of direct addressing mode. Okay, so those instruction actually coming in the group of direct addressing mode. So this is, so I have underlined this portion because this is important. Okay, and lower, this is also not only in target SFI, it is also targeting lower 128 byte of RAM. Okay, next is your register indirect addressing mode. So what is register indirect addressing mode? I have already told, okay, discussed with you. So it is the content of R0 or R1 is used as a pointer to memory location. Okay, and of 256 byte size. So 256 byte size, why I have written here 256? Ankita microphone is on. Ankita. Okay. So why I have written here 256 byte size? Because you see here register indirect addressing mode, it is targeting the internal RAM. Okay, and what is the size of internal RAM? Is 128 byte. That means 7 bit. 7 bit combination. 128 byte means 7 bit combination. So but if I is there any provision to put only 7 bit? Answer is no, because the data length is 8 bit, right? So 8 bit means 2 to the power 8, that means 256. So though the size of internal RAM is 128, but through when I am pointing that location of the internal RAM through R1 or R0, which have the size of 8 bit length, so the space, that memory space, we can is becoming the, so the memory space will be your 256, 2 to the power 8, 256 byte size, right? Okay, so I think you understand why I have written here 256, because the register length is 8 bits, so 2 to the power 8, 2 to the power 8 is 256. Okay. Okay, so next is your okay, and another thing I have here highlighted, SFR cannot be accessed. So this, using this addressing mode, we cannot access SFR. Okay. Much. Okay, so okay, I think it is clear. Okay, just 1 second. So the memory space that is used here is the internal RAM by using these three parts. Okay, and also we can access the external RAM also using same to register, but stack pointer is not used because external RAM is size of external RAM is not 8 bit dependent, it will be size of so in that case I have to take the help of DPTR. Okay, so stack pointer is cannot be used in that case, so some provisions are given, limitations are given. Okay, so stack pointer cannot be used for external RAM, here it is used for only internal RAM. Okay, so next is 1 second. Okay, so next is your immediate addressing mode. So this is where you are providing the immediate data, so that is quite simple and straightforward as 8085 also, but it is used for program memory. So this is the point. And finally the base register plus index register indirect addressing, where you are providing some you are using, so it is used to access a byte from program memory, so it is also something that is related to program memory indirectly from the location where the address is sum of base register and index register. Okay, so from the base register plus index register we can go to any location in the program memory and access the data. So basically this is used in lookup table cases. Okay, lookup table cases where you have to jump from one location to another location, so for similar to jump, this addressing mode is used. So basically in 8051 we have 5 addressing modes, and 5 addressing modes target different memory space, and they will behave in a differently. That is what I have written in this note. Okay, and next is your instruction format. So in as 8085 we have different kind of instruction format, so similar to that 8051 has a different kind of instruction format, but we are not going too much depth with this topic because uh, because it is not because of the time constraint, you understand that. So basically just for a basic and totally a basic things I am going to discuss it with you here. So suppose in the similar to 8085 it has 4 addition instruction. Okay, 4 format of addition instruction. Okay, so that formats are like this: add a comma rn means n equals to 0 to 7, so any of the register. So where add so what is this instruction? This instruction is addition of content of accumulator to with specific working register Okay, so that is Rn, working register, and result stored in the accumulator. So that is totally quite similar to 8085. The content of accumulator adding with content of register and result storing in accumulator. Okay, so next is, so what is the format of this? A add a comma r0, r1, r2, r3, r4, r6, r7 up to 7. Okay, so add a comma direct. Direct means the address, direct address. Okay, so add the content of accumulator and specified address this content and place the result into the accumulator. Okay, so add a comma address location. So from that location the data will be copied. Data will be copied. Data will be added directly to accumulator. Okay, so next is your add a comma at the rate ri. At the rate is when we are using at the rate, when we are using register indirect addressing mode. So you see here, addressing register indirect addressing mode, we are using at the rate. So here at the rate I means I equals to 0 or 1. So register indirect addressing mode it is. So here we are adding the content of the memory location and the content of the memory pointed by the ri. Okay, with the content of accumulator, and the finally result is stored at the accumulator. Okay, so this is the way, this is the way of addition of accumulator with the content of any memory location through indirect addressing mode. So so you see, in this addressing mode I have not given any example, right? So corresponding to those, the examples are like this. Here it is the examples of corresponding four, but for the fifth one, that will be a different example that is not shown here. Okay, so here it is, add a comma at the rate ri. So this is register indirect addressing mode. Okay, and add a comma ra, this is register addressing mode. Okay, so this is immediate addressing modes and this is direct addressing modes. Okay, so here how we are giving a data. When we are giving out any immediate data, we have to use hash, this hash tag. Okay, we have to use this character has data, so it will considered as data and it will immediately added with the accumulator and result will store as accumulator. So this is basically, so to add any data with accumulator we have total four provision. We can directly add the content of register with accumulator. We can directly add the content of memory location with accumulator. We can indirectly add the content of memory location with accumulator through R0 R1. We can immediate add the data with accumulator. Okay, so we have total four provision. Okay, so here I have given only small two examples to understand the this instruction, basic instruction format. So suppose I have to add two data, that is 57 and 6ah, and store the result into a memory location that is 52. Okay, so here two data are given, that is 57 and 6ah. Okay, so before giving this example, yeah, you just write down your id here. Okay, so let's take your attendance. Okay, so you just need to write it down, your ID. Just 5 minutes. I will discuss these two examples, then you can leave. Can leave. Okay. So example number one is your you have to add two data, that is 57 and 6a. Okay, and store the result into a location 52. Okay, so to do this, you have to use this instruction mov instruction also there in 8085. Okay, so mov a comma, as this is a data, so has 57h. Okay, you understand why has, because this is a data. And which kind of addressing mode it is actually your immediate addressing mode. Okay, next is, yeah, add instruction, it is also there in 8085. Add a register name accumulator comma the next data, that is 6a, has 6ah. So after this second instruction, after execution of the second instruction, the content of accumulator will be added value of these two data, right? Then you have to move that data. So here now you see, as in 8085, is in 8085 there is a instruction LDA or STA, right? So suppose we have to add two data, then I have to store that result into memory location, then I have to use STA here, not MOV. I have to use STA, then address of that location. But you see here, this is the different. As in 8051, as I have told you in the starting of the microcontroller class, says that microcontroller is the application specific and it is very fast. Okay, it has not wide application, but it has some unique application, but the factor is it is very fast to execute that application. So that means you see mov instruction are used here, not STA or LDA. That means here we are reducing the execution time. Actually, there is no such kind of instruction LDA or STA in 8051, because all the instructions are shorter in execution time. Okay, so MOV 52 comma A. So content of accumulator will be stored at, will be copied to, or will be written to the memory location 52H. Okay, you understand? And what is 52H? 52H is the memory location of internal RAM, not ROM, because it is a data, so it will be part of RAM. Okay, so that is also that thing also you understand. Okay, so MOV is your internal RAM location where the content of added value will be written. Okay, so finally result, if you see, the result is at the location 52H, you see C1 is your result. So this is the example. So in this example, we understand how we can put immediate data and how we can move that result into a memory location internal RAM. We don't have to use LDA or STA instruction. Okay. So next is add 35H and 63H. Okay, using pointer. So similar to previous one also. Okay, similar to the previous one. Here little different is uh, you have to use some pointer. Okay, so when I am saying use some pointer, it means it is a register indirect addressing mode. Okay, so you need to understand. Ankita, your microphone is on. Ankita Satra, your microphone is on. Okay, so that means I am referring something that is register indirect addressing mode. Okay, so that's why I have written here. You have to use R0 as pointer. Okay, and as R0 as pointer. Okay, so that is the problem statement. You have to add two data using pointer, and R0 is used as a pointer. Okay, and what is the note here? note is by default when you just turn on the 8051 key, it will be at bank 0. Okay, so by default bank 0 is selected on reset. So whenever you on or reset the 8051 key, the bank 0 is the default bank location. Okay, so R0, so here that R0 belongs to that bank 0. That's why I have written this note. Okay, so to execute this instruction, this program, what we have to do? Okay, one thing I have not written here, so I have shown in this format. So actually these two data are not directly as the previous example where you are directly giving some data, but here these two data are available at the memory location 51 and 52. Okay, so 35 is the first data available at 51, 63 is the second data available at 52. So you have to fetch that data, okay, from this location 51 and then add. Okay, so as we can directly do this thing, we can directly do this thing using mov instruction. Okay, mov a comma 51 h will directly copy the data into accumulator, but we cannot do this because we have to use here pointer. So I have to initialize that pointer first. So here I am initializing that pointer. So I am giving mov r0 comma has 51. So that means this is the data, immediate data that is stored into this register. Okay, that is good. But what is that data? Actually, this is not only data; it is also a memory location. So 51 is also a memory location. So when I am next in the next line, when I am executing this instruction mov a comma at the rate r0, that means it is telling a microcontroller that you have to go to the value of 51h location. Okay, so here then as it is at the rate, that means you have to take out this data, so 35, and put it into accumulator. So accumulator will be the will store with the data 35h. Okay, so next is, so I have the first data. Now I can directly add. So I have used the pointer also, so purpose is solved. Now I can directly use this instruction, add a, that means it is a containing your first data, then comma 52h. So 52h is not your data, actually this is your next location. So this is your direct addressing mode, right? So add a comma 52h, 52h, the 63 will be added. Okay, so after addition we have to move the data to the next memory location result here. So move 53h comma a. So you see the destination first, then source, same format at 8085. Okay, so 53h comma a. So finally result will store at 53h. Okay, so basically these two problem is required. Okay, so as there is no, there is some time constraint, so I am not going too much into the instruction set because we have already gone thoroughly all the instruction set, their execution, their timing diagram, machine cycle, byte size, everything for 8085. But in 8051 I am just giving you a little brief of a very basic brief of the instruction, how this instruction will work. So this is the data. You understand that how we can give the immediate data, how we can fetch our data from memory location using MOV, how we can use a memory pointer using register R0, right? How we can take out the data after using memory pointer. Okay, so this all stuff you understood too. So basically, this is a very important topic for your ESA also, and I think you understand the thing, the concept of two things. One is your addressing mode. Okay, five kinds of addressing mode, how the addressing mode will affect the memory space, or which memory space will be used for these addressing modes, and their description. Then how types of instruction format, some addition with respect to addition, and two examples. Okay, so that's all for today. Is memory interfacing for memory interfacing Memory interfacing, I don't think I have covered that part. Then if I not covered, then that is not in the syllabus. Okay, so I will check it out also. Okay, thank you.